Okay, so this video is for my Algebra 2. We have a Chapter 3 quiz on Monday, and this is to prepare you for that quiz. So let's take a look at this problem here. Okay, we need to graph this system of equations to solve it. And I'm actually going to change the bottom equation just slightly. I'm going to change it to y equals negative x plus 2. Okay, so the top equation stays the same, the bottom one will change. Just so we have one that's in standard form, x and y on the same side, one that's in slope-intercept form. So let's take this top equation, and it is x and y on the same side, so to graph it, let's find the x and y intercept. To find the x-intercept, let's erase the 4y, so 2x equals 12, and we'll solve for x by dividing by 2, and we get x is 6. For the y-intercept, we pretend the x is not there, so get rid of the 2x. 4y equals 12. We divide by 4, and y is 3. So I'm going to go ahead and graph that. I'm going to put x is the horizontal line, go over 6. 1, 2, 3, 4, 5, 6. Put a dot there. Y is the vertical, go up 3. 1, 2, 3. And we'll connect it with a straight line as best we can. Hopefully you have a straight edge that you're working with. I, on the other end, do not, so I try my best. Okay, not too bad. And there's my line. Remember, this is not an inequality, so there's no shading. There's no solid or dotted question. It is a line. And now we graph the second one. And again, we changed it into slope-intercept form. Y equals mx plus b. So the first thing we find is the y-intercept, and that is the b. It's 2. So we're going to go up 2 on the y-axis. The second thing we look for is the slope. And there is a minus 1 in front of that x. That is the slope, negative 1 over 1. And that is going to be down 1 and to the right 1. Okay? So what I'm going to do is I'm going to graph my y-intercept. I'm going to go up 2, 1, 2. And I'm going to count the slope a couple times. Down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1, sure. And I'm going to connect those dots. The more dots I think, the better the line I'll have. So I'll come down this way, right? And I'll go up this way. And there. And there's my two lines. So the goal of this problem is where do they cross? And I'll put where they cross in black. And down here in green I'm going to put what the point I think that is. I think that is negative 2, 4. I'm not sure though, but I can check. And you're going to have to check. See, it says check. To check, just plug it in to each equation. 2 times negative 2 plus 4 times 4. Does that equal 12? Well, 2 times negative 2 is negative 4 plus 16. That is 12. It works. Now this one's a little different because y is on the left side. So if you plug in x, negative 2 plus 2. This is positive 2 plus 2, which is 4. And look at your y value. Your y value is 4. This works, right? Because that equals y. So just plug it in for x and y. Make sure the left side and the right side are the same. 12 equals 12. 4 equals 4. We're good. This is my solution. Next. Okay. We're going to determine whether the system is, now I crossed off independent. We don't need to know about independent. Independent is the problem we just did. They're going to want dependent or inconsistent, okay? And let's talk about what each one means. Dependent. Dependent means that your lines are exactly the same line. Red and blue. They're on top of each other, okay? So this would be the same equation. Inconsistent would be a picture like this, where the lines never cross. Parallel lines. And for parallel lines, your slopes are equal. M's are equal. So when we have this problem here, and it says without graphing, what they want you to do is put them in slope-intercept form and compare the equations. Now, the second one is already done for you, so we only have to work with the first one. So I'll put that right here. 2y minus x equals 4. To put this in slope-intercept form, get the y by itself. Let's add x to both sides. 2y equals, put the x first, x plus 4. And then we'll divide by 2. And I'll do it all 3 places. Y equals, the x has a 1 in front of it, so this is now a 1/2 x, and the positive 4 becomes positive 2. And this is the top equation, and I will write it right up here. Y equals 1/2 x plus 2. And now I will compare the two equations. If you look at these two equations, they are the same. Same equation. If they're the same equation, then your answer is dependent. These two equations are a dependent system. 3. You can choose between 2 tennis courts at 2 university campuses to learn how to play tennis. One campus charges $25 per hour. The other campus charges $20 per hour, plus a one-time registration fee of $10. Write a system of equations to represent the cost. Now we're going to let the cost be y for x hours of court use at each campus. Okay? So let's start with part A. So x is the number of hours, y is the cost. So let's go with the first campus. On the first campus, all they do is charge $25 per hour. Okay? Per hour means put the x with the 25, and that's the total cost. Y, the total cost, equals 25x. That's it. There's no fee here. There's just a $25 per hour. Now, the second equation, the other campus, charges $20 per hour, so that's the same thing here. But it also charges plus a one-time registration fee of $10. So the total cost here is 20x. The per hour means put the x with the 20, plus the one-time fee of $10. So that's just plus $10, plus 10. Here's your two equations. Okay. Now part B says find the number of hours for which the costs are the same. Okay? So the idea is find x when y equals y, when they're the same, when the costs are the same. So we want to know what is x when y equals y. Well, if we want to know when y equals y, set these two things, 25x, equal to 20x plus 10. Set them equal to each other. This is sort of a form of substitution. You know, they're both solved for y, so you're taking 25x and you're plugging it in here for this y. So you're taking this y out and putting 25x in its place. Either way, set them equal and solve. Subtract 20x from both sides. We get 5x equals 10. Divide by 5x equals 2. So what they're saying is if you play for 2 hours, it doesn't matter which campus you choose, it's going to be the same. So after 2 hours, or at 2 hours, the costs are the same for both places. Okay. I'm glad you watched this. There's a problem just like it on our tests, so make sure you pay attention. 4, here we go. Write and solve a system of equations. A store sells small notebooks for $8 and large notebooks for $10. If you buy 6 notebooks and spend $56, how many of each size notebook did you buy? When you are looking for the variables, which is the first step, you look for the question. The question has the question mark. So x and y, how many of each size notebook? X is going to be the number of small notebooks. Y will be the number of large notebooks. And we set up our two equations. The first equation has to do with money. Every small notebook costs $8. Add that to $10 for every large notebook, and you spent a total of $56. This is all money. The other one has to do with the number of notebooks. The number of small notebooks you bought was X. The number of large is Y, and you bought a total of 6 notebooks. Remember, the second equation is the simplest one, but it's the hardest one because you overthink it. Don't overthink. X plus Y is 6. And now we solve this either using substitution or elimination. I'm a fan of elimination. I'm going to eliminate the x's. I have an 8x here. I can make this x become a negative 8x by multiplying that equation by negative 8. And I do it once, twice, 3 times. So over here, the top equation is the same, But now the bottom equation is negative 8x minus 8y equals negative 48. These are called additive inverses, right? I got the x's to be the same number but different sign. And now I combine the like terms down. And the x's cancel. You get 2y equals, and this is 8. 56 minus 48 is 8. Divide by 2, y is 4. You bought 4 large notebooks. So now, how many small? Well, you pick one of the equations and plug it in. I am going to pick the bottom one because it is the simplest. X plus my y is 4 equals 6. Subtract 4, x is 2. 2, so I shouldn't circle that, I should circle 2 small. So I got 4 large notebooks and 2 small notebooks. Okay, next one, here we go. A gardener wants to plant at least 50 tulips and rose plants in a garden, but no more than 20 rose plants. Write and graph a system of equations to model the situation. So, this is a inequality problem. Notice the type of graph I give you, L-shaped. Same on the test, because we're working with words, real life stuff, no negatives. Now, we need variables, x and y. And in this problem, there's really no question. So what are the two things we're talking about? Well, we have tulips, and we have rose plants. So what are the two sentences that deal with our inequalities? Well, this says you want at least, I'll do it in red so you can see it better, at least 50 tulips and rose plants. So together you want x and y to be at least 50. So that means you're okay with being 50, but you want more than 50. Greater than or equal to 50. The other sentence, the other part of this, no more than 20 rose plants. So now we're only talking about rose plants. So that means you're only talking about y, no x, and you want no more than 20. So that means you're okay with 20, but then you can't have any more, so you have to have less than 20. Less than or equal to 20. And there's your two inequalities that you need to graph. Okay? So here, this first equation, x and y on the same side, find the x-intercept and y-intercept. X is 50, and y is 50. Okay? So I need to count by something so I can get 50. Let's count by fives, right? Fives. So I'll do it in green here. So we're going to count by 5, 10, this is 15, 20, 25, 30, 35, 40, 45, 50. Sorry, it's so small. I'll do the same thing on the y-axis. So 0 is here. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Let me make sure. 20, 25, 30, 35, 40, 40. Yeah, so this is 50 right here. And this is 5, 10, 20, 25, 30, 35, 40, 40. Yeah, that's 50 up there. Okay, so we're going to graph the orange. So put x-intercept of 50 here. Let me do it in red because it'll show up better. And a y-intercept of 50 up here. And the line is solid because it's equal to. So I'm going to make a solid segment between them. And I need to know where to shade. And for this equation, because x and y are on the same side, let's test 0, 0. When you plug in 0 and 0 for x and y, you get 0 is greater than 50. 0 on the left side. This is false. So if 0, 0 is down here, 0, 0 is here, I'm not going to shade towards 0, 0. I go away. Okay? And now the other equation, this is a special kind of line. What it's saying is every y must be 20. So x can be anything, but your y must be 20. Go to where y is 20 on the y-axis. 1, 2, 3. This is 20. And now x can be anything. So I can go this way or this way. So see what kind of line I'm drawing? I'm drawing a horizontal line. That's the kind of equation this is, horizontal. So I'm going to draw a horizontal line, solid because it's equal to solid, straight down, sideways, if I can draw sideways. And since it's solved for y, we can just use the shading based off the inequality symbol. Less than means below. So we're going to shade below. So the area that we're working with, I'll do it in black, is this right here. That's the area. And now let's just pick a point that works. I'm going to use green. It might not show up very well. I apologize. But if I look here, just pick some random point that's nice. I'm going to pick this one right there. Okay. And what I want to know is, what are the coordinates of that point? The coordinates of that point are 50, and that looks like 5, 10, 15. So what does this mean? Well, that means this point represents 50 tulips and 15 rose plants. That's what that means. And if you notice, does that satisfy the inequalities? Well, you have 65 total, which is greater than 50. That's what you want. And your rose plants are less than 20, which is also what you want. So this is a great example of a set of tulips and rose plants that will fit this system of inequalities. Okay. All right, good. Last problem here. Uh-oh. I'm going to have to adjust my graph. I fit it. Okay, there we go. So there it is, all fit in the window. Here we go. Graph the system of constraints. Name all the vertices. Find the value of x and y that maximize or minimize the objective function, and find the maximum and minimum value. So there's my constraints, all those inequalities. We're going to find the maximum of that objective function, p equals 2x plus y. And we'll probably do that right up here. But first thing I need to do is I need to graph these inequalities. Actually, I'll do the graphing up here. So the first thing, these are the first quadrant. First quadrant. So notice I gave you the L shape, so you should be drawing an L shape. That's the y and x axis. Okay, so let me actually do that in black. Okay, so that's quadrant, as I said, quadrant 1. So now let's graph these other two inequalities. So they both have x and y on the same side, so let us find the x and y intercepts. And I am going to work it down here. It's just easier for me. So the first inequality, 3x plus y is less than or equal to 7. Let's find the x-intercept by setting 3x equal to 7. Let's divide by 3, and you get a decimal. It's okay. You get 2.33, and that's good enough. For the y-intercept, y is 7. So on my graph, I'm going to count by ones. On the x-axis, we're going 2.3, 1, 2, and a little. And on the y-axis, go to 7. 1, 2, 3, 4, 5, 6, 7. The line is solid. So do your best to be as exact as you can. And I need to figure out where I'm going to shade. It is an inequality. So test, and we're going to test the point 0, 0. Test. 0 less than or equal to 7, that's true. 0 is less than 7, so we're shading this way. And notice how I stay on the right side and above the axes. And now let's do the other equation right here, right down below. X plus 2y equals 9. So for the x-intercept, x just equals 9. And for the y-intercept, 2y equals 9, so divide by 2, y is 4.5. I'm going to make a solid line, so let's put those 2 points. X is 9. Don't make this mistake of putting on the wrong axis. You can't do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Y is 4.5. 1, 2, 3, 4.5. And now we'll make a solid line, solid segment as best you can. That's as best I got. And where do we shade? Well, we test. Test 0, 0. 0 is less than 9. That's true. So we're going to shade below. And now we really are looking for where the overlap occurs. And that overlap occurs in this quadrilateral right here. The points of this quadrilateral are here. Let me use green, see if it'll show up. So the points are here, here, down here, and here. So what are the coordinates of those points? Well, this is of course 0, 0. This was the x-intercept of the red graph. The red is my orange over here. That's 2.330. This was the y-intercept of the blue graph, so that's 4.5. So we have 0, 4.5 up there. And now this is the point that I'm really interested in. You have to be exact when you graph. That's the point 1, 1, 2, 3, 4. So now we're going to plug all of these into our objective function here. So I'm going to do it right here. 0, 0, 2.330, 0, 4.5, and 1, 4. And let's see what we get. PE equals 2 times 0 plus 0, that's 0. PE equals 2 times 2.33 plus 0, and that is going to be 4.66. PE equals 2 times 0 plus 4.5, and that's 4.5. And PE equals 2 times 1 plus 4. 2 times 1 is 2 plus 4 is 6. And if I'm looking for the maximum, I look for the biggest number, and the maximum is 6. So the point 1, 4 maximized this objective function and gave it a value of 6. So there's the YouTube for the quiz. A little bit longer, sorry about that, but this is a great review for you, and you should do very well on the quiz. Alright, thanks for watching.